So my name is Sander, and I have a confession to make. I like building monoliths. There, I said it. So maybe I should go look for a support group now, anything like that. But you know, I think there are many people like me in this audience, right? All we hear at conferences is microservices this, microservices that, how awesome they are, how to use them, what the best practices are. It's almost like there are no different architectures anymore than microservices architectures. So this talk will give a different view. And it might be a view that you disagree with, that's fine, but it's my view. And I think there's a better, or in some circumstances, better alternative to microservices in modular application development. So that's not to say that I hate microservices or I think they're never applicable. It's just that we're currently at this top of the hype cycle, right? Everyone's talking about it, and you're not cool if you're not doing microservices. And I think lots of people choose microservices for the wrong reasons. And to not become one of those people, I'd advise you to pay attention. So about me, like I said, my name is Sander Mark. I'm a fellow and software architect at Luminis, and we develop software, obviously. We do this for clients, and we also build our own products. And when building those products for ourselves, it obviously is advantageous to us to have a stack that is extensible, to have a stack where we can create maintainable software, where we can actually keep on developing it after years and years of development. Because let's face it, if you're a consultant and you're the client and you build something and you're out of there, well, who cares whether it's maintainable? But if it's your own software, you care, trust me. So we do we have a lot of experience in modular application development. Mainly in the Java world with OSGI, the past few years. But as you may know, or may not know, but now you know, in Java 9, there will be a new module system that's coming up. There's also a book that I'm currently writing about that together with Paul Bakker. So we really think this is a big step forward for Java itself. And to be fair, this talk won't be about Java and Java 9, only in part. But of course, this is the reason why I got into this material, why I care about modularity. So I've given quite a few talks about Java 9 and the module system. And almost always at the end, someone comes to me and says, yo, listen, didn't you get the memo? We do microservices now. So why should I care about this modularity stuff and the modules in Java? When should I use it? And as you do after a conference, you're wrapping up your stuff and you try to come up with an answer and sort of give half of an answer. So you should consider this my definitive answer to that question. When should you go the microservices route, and when should you at least consider doing modular application development inside of a monolith? There, I said the word again. I don't think they deserve the bad reputation that they currently have. So this talk has a question as title, and I don't want to leave you guys hanging right until the end, until I give the answer, so I'll give it right to you now. The answer is yes. Okay, I know you're all developers, right? So you're forgiven to have thought that this might be an exclusive OR. It's not. It's just a regular OR, so it can both be true. I think there's a place for both modular application development and microservices. It's just a question of when to choose the one or the other. And of course, being the consultant that I am, I just give the perfect consultant answer. It depends, right? Depends on your software, depends on your people, depends on your company, etc. But of course, there are more important questions to ask, and we'll get to those later. But before we do that, I think it's good to talk about modularity itself as well. And modularity is a concept that is sort of vaguely familiar to everyone, right? And it sounds like a good thing. But what is it actually? So to illustrate this, I want to step outside of the boundaries of software development, and I want to show you this. So I took this picture. Well, actually, I wish I took this picture. But anyway, I found it on the internet and I put it on a slide of the ISS, which is a marvel of engineering, right? It's just incredible that it's right up there. And it has been built over a span of 20 years, more than 20 years. People from all over the world participated in the construction of the ISS. And really, it's amazing that this thing actually came together and works and delivers on its promises already for 20 years. That's something that we would like for our software as well, right? So how did they do this? It's not by sheer luck or chance that this happened. No, this is the essence of modularity. There were distributed teams across the world building different modules for the space station, and they didn't really care about all the details of the internals of the other modules, but there were interconnects, right? There were interfaces between those modules. And as long as those interfaces are specified, are really agreed upon upfront, those teams could work in isolation, in parallel, and they could create a space station in a distributed fashion, right? So applying this to software, I think, is one of the most important architectural principles. We want to be able to work in parallel on our applications. We want to be able to extend it without knowing what's next, right? We don't know upfront what it is that we're going to build all the time. Still, this might be a bit vague. So let's make it a bit more concrete in the context of software development. If you talk about modularity and software development, I think there are 3 core tenets or 3 core principles that you should always think about. And the first one is strong encapsulation. So when I talk about strong encapsulation, it's actually about being able to hide stuff. And it may sound a bit counterintuitive, right? So why would you want to hide stuff? Well, it actually makes a lot of sense when you think about it. Because the more stuff you can hide from other people, the less they know about the thing that you built, and the less they can depend on those details, right? If you build a software component, and everybody knows about all of the intricate details that went into the construction of this component, and they actually use their knowledge of these details, then you cannot change these details anymore. They have become part of your API, of your component. So you want to hide as much as possible, and as strongly as possible, because there are always people who will try to get at your internals, and you want to try to prevent them from doing that. Of course, you cannot hide everything, right? If you want to have useful software, the components need to communicate, like in the ISS, where you had those interface points between the different modules. So yes, when you're talking about modularity, hiding stuff is important, but it's equally important to also have a public part of your component, an API part of your component, that is stable, that is well-defined, and that people can actually depend upon. And these might be Java interfaces, but these also might be REST interfaces. I mean, I'm not talking about technology here, I'm talking about principles. We'll get to technology later. The last one has to do with the fact that if you start modularizing software, you will end up with lots of parts, right? That's the idea. You want to have separate parts where people can work on separately, which have their own defined purpose, which you can see nice boundaries around. But those parts, they need to work together through the interfaces that you agreed upon. So you want to make those dependencies explicit as possible. And hopefully not just on the whiteboard, but also in a way that the tools that you use to create software help you in following these dependencies, in creating an actual application out of all the parts. So for us, we like to say that modularity is the ultimate agile tool as well. Because if you adhere to these principles, and if you have a technology stack that enables them, it allows you to replace parts easily, right? It allows you to change internal details without the whole application falling over because, well, you have those boundaries, you have the strong encapsulation, you have all the knowledge of the explicit dependencies, so you know if you change something in the module here, and if you change something in this API, then you know all the dependencies that exist towards this API. So it gives you a way to assess impact of changes, and it gives you a way to change software easily. So still, this is only abstract, right? Without going into any technology choices yet. So let's talk about microservices first. And there's no common agreed upon definition of microservices. So when I talk about a microservice, I talk about a independently deployable software component, an independently running process as well, which is implementing some business capability. So if we're doing microservices, hopefully we're not doing all these little technical services, but we're doing business services And they are scoped to a single domain. They try to do one thing and do one thing well. And most crucially, these independently deployed processes, of course, communicate over a network. And this can be, like I said, a REST call, but it can also be through queues, events, whatever, it doesn't really matter. In the end, there's always some communication happening between those microservices over the network, right? So I want to show you this, and it sort of looks like this. Now I look at it. Who knows what it is? I'll give you a little hint. This is the Microservices dev room at the FOSDEM conference earlier this year, which is an open source conference in Belgium. And it's packed, right? I mean, that's good. Everybody loves microservices, I think. Well, I see people in despair, right? Oh my, what have I gotten myself into now, right? They're praying for a better solution. This can't be it. Really? All this complexity? Yeah, so I think you should reassess. Microservices are hard. I mean, everybody agrees to that as well. So I think we need to have a little introspection here, right? Because I'm not saying you should never go down the microservices route, but you should do so for the right reasons. So you should think about when to do it and when not to do it. So, of course, when I'm saying you shouldn't always do this, I should also give you an alternative. And this alternative is modular application development, using module systems in various technology stacks, not just the one that I like, in Java 9, of course, but various technology stacks offer modularity mechanisms. And we're going to look at those. Now, a good question to ask is, why do most people go to microservices? It's partly because of hype, of course, but there's also some substance, right? So people do this because they have complexity that they cannot manage anymore. They have this big application and it becomes hard to change. It becomes harder and costlier to change. And in the end, it falls over and development grinds to a halt. And they cannot move past that. So I would say this is actually a cry for modularity. This is a modularity in disguise problem. Then there's also other problems, of course, why people move to microservices. Those have to do with scaling and resilience and fault tolerance in your architecture. And we'll get to those later. But let's first focus on this management of the complexity by going to microservices. Because yes, of course, it's very nice if you can have sort of an architecture like this, right? And I'm currently building an educational system, so forgive me the examples, but we're talking about learning materials, students, grading, courses, attendance, all nice business capabilities that can be chopped up into their own microservices. And when you talk about microservices, then often people contrast this with monoliths, right? And those look like this. Yeah? No? Well, no boundaries, everything hooks into everything. There's no real modularity going on here either. So yeah, undocumented spaghetti code, you could say. That's a bit unfair, but this is how people look at it. However, there's a reason why those monoliths exist. That's because if you start building them, it's very cheap to do so. I mean, you just start coding, right, in your favorite stack. Don't think too hard, just do it. But what you end up is with a situation where you sort of hit a brick wall, where you want to build more features, but it just becomes too costly or even impossible to extend it anymore if you have this spaghetti code architecture thingy going on. And then there's the promise of the microservices, right? So you have this nice linear scaling. Okay, it comes a bit more costlier if you have more services, but well, you can just add a team, and a new team will just build a new service, and they won't bother the old team, and everything will be fine, right? So that's sort of the promise. But what people often don't see in this graph is this, right? There's a real cost associated with going from monolithic development to microservices development. And I'm not just talking about money. I'm also talking about complexity overhead. People need to know a lot more when they start building microservices than they need to know when they're building a monolith. So what do they need to know? Well, for example, if you're doing microservices, you're actually creating a distributed system, right? So each of these nice individual boxes actually aren't really individual boxes. They have some sort of connection, right? So users do something with learning material, and students get grades and follow courses, and there's communication going on here. So they need to find each other. So you do service discovery, and you use tooling for that, for example, a console or etcd, or something from the Netflix microservices stack, because of course they have an awesome and nice, very cool open source stack around all the microservices tooling. But yeah, you have to select this, you have to know about the tools, you have to implement them. And the same holds for everything that can go wrong with networked services. So we all assume the network always works and there's no latency and blah, 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 all the fallacies, you know them. But in practice, you have to defend against them. If you're building microservices, you need to do something like circuit breakers, bulkheading. Well, you probably heard all the talks at conferences about this already. So there's lots and lots of more interesting things going on there if you're going to build microservices. And then there's the whole logging, tracing aspect. You have tools like Zipkin that you can use to do distributed logging and tracing. But then again, this is all just on top of what you're already developing for the domain. This is all what I would call accidental complexity by going to microservices. And I'm not saying those tools are bad, right? Some are great, some are good, some are not so good, but that's the whole point. You need to find out, you need to learn this. You need to really move to that, to do microservices. And then we have deployment, right? Well, that's a solved problem. We're just going to do Docker images. Well, not so fast. Where do they run? On what infrastructure? I mean, in the end, you need some cloud or metal beneath, and you need to orchestrate these Docker images. Or maybe even you should do Rocket instead of Docker. And there's many more container image formats, etc. So again, choices, choices. Complexity, complexity. What about configuration management? Well, if you have all those services, you might have multiple versions of the services, and maybe version 1 does talk to version 2 of students, but it doesn't talk to version 3, so you need to be aware of that. You need to route around that. You need to do configuration management. You're going to have to replicate this, of course, at least 4 times for your development, test, acceptance, production environment, etc. So again, it's not groundbreaking. I'm not telling anything new, but I just want you to feel what it means to do microservices. And we've seen lots and lots of tools already, right? And lots and lots of complexity that you probably haven't thought about if you're currently doing single application development. Then, of course, security. Yeah, you're doing machine-to-machine communication now, which is quite different than just securing your normal web application. And again, these are all solvable problems, but they're also non-trivial to get right. So yeah, there's a real cost here. And it's not just a cost that you can magically get away by going to vendors, because I hear lots of people saying, well, we have this nice stack and it solves everything for us. And to a degree, there are some nice stacks that do the tool selection for you already, right? And they help you, and that's good. But in the end, this won't magically transform your engineering organization into an organization that knows how to do microservices, and that knows what all the pitfalls are, and that knows what it actually means to operate this. So yeah, that's the thing. So let's talk about modules, right? Because we saw this nice stack of microservices, and it looks really inviting, right? You can have separate people working on the separate services. So what would this look like, not as a monolith, but as what I would call a modular application? So surprise, surprise, it could actually look quite the same, because there's no reason why you cannot model the modules in your application along the same boundaries as you would do with microservices. And I hear some of you thinking, yes, but it requires discipline, and if we don't have this discipline, we end up in the spaghetti code again. And that's partly true, and that's also partly solvable by selecting tools that help you apply these modularity patterns. We'll get to that. So what this gives you is sort of a middle-of-the-road option, right? We don't have all this initial cost of going to a fully distributed microservices setup, but we have a way of developing modular applications that helps us scale development to more features. And yes, it's not as linear as the microservices approach, I fully admit that, but also it's less costly to do so from the get-go. And the question is, of course, what does this entail? What does this look like? So many people think when they hear me talk about modularity and the principles of modularity, so this is about objects, right? We have public fields, private fields, and the sort of encapsulation, and they use each other, so you have dependencies between classes. So yeah, true. In the small, those are also modularity patterns applied, but we're thinking about modules as something bigger. They need to be below the size of a complete application, of course, but above the size of individual source files or classes or what have you. So we need something at the level in between of the application and the low-level primitives to manage the complexity of your application. So we can use module systems to do so. And as I said, for example, if you're on a Java stack, for a long time there has been OSGI, which has become the de facto standard for module systems in Java. Some people like it, some people don't, but it does bring real benefits in terms of applying modularity principles. But the nice thing about Java 9 is that it will bring the module system natively to the language. So it's not just an add-on anymore, it's something that you really can use and really will be supported by the compiler, by the Java virtual machine, etc. So something's happening there in the Java world. Then JavaScript. Well, yeah, of course, it's JavaScript, right? So there are tens, 20 module systems, I don't know. You could choose one. But fortunately, they also standardized on a single module system in the ES 2015 version. So something is happening in that world as well. And even when you look at C++, which is, of course, an ancient language by many standards, but in the revision of C++ 20, which will be upcoming in 2 or 3 years, they are already prototyping a module system there as well. And if you're doing .NET development, well, there's approaches that you can use, like using NuGet packages. If you look at .NET Core and everything that's happening there, .NET Core itself is also very much about modularizing the .NET platform itself. So let's dive a bit deeper in some of these stacks and judge them by the strong encapsulation, well-defined interfaces, and explicit dependencies principles. So looking at Java 9, what we used to have in Java is the ability to have jar files, right? These were sort of small pieces of an application that you can combine together, and then you get a whole application running out of many jar files. But there were many problems with those. Essentially, if you have a jar file, it could depend on other jar files, libraries, other application components, but you don't really know which jar files, because there's no explicit dependency information inside those jar files. So if you start an application with a class path filled with jar files, you could be lucky and it could work, or you could be unlucky and it could break instantly, or it could break at some point when some unsuspecting user clicks a button somewhere, leading to a class load for a class that's not there. So that's bad, right? You don't have any reliable dependency management in that sense. The other thing is that jar files, they look like those nice modules, right? But what happens, in effect, when you put them on the class path, is that they're flattened out into a big list of classes, which is just linearly scanned by the JVM whenever a class needs to be loaded, without regard for the boundaries of these jar files. So any public class in any jar file could use any other public class in any other jar file, giving you, well, yeah, spaghetti dependencies if you weren't really careful. But with the module system, we get a new tool. And what we see here is a module descriptor, and this is the source form. It can also be compiled and be part of a jar file. And it contains a definition of a module in Java 9. So what this gives is strong encapsulation, because by default, anything that's in a jar file with a module descriptor cannot be accessed by any other module, unless you export a certain package or packages. So this is the well-defined API that you expose from your module to other modules. The other thing that we see here is that we have require statements, which say this module, in this case attendance, requires the students module and the courses module. So what happens is that both at compile time and at runtime, the compiler and the JVM will verify for you that those modules are present. And if they're not present, they will say to you, please make sure these dependencies are satisfied. So that's much more reliable than the situation that we had with ClassPath. Now this is a picture of the modules in the Java platform itself. So the platform itself has also been modularized, whereas previously it was a big, fat jar file containing all the Java library classes, tens of thousands of classes, with all kinds of nasty dependencies. They were able to modularize the platform itself, and as you can see, we can now inspect the dependencies between all the functional components there, and we can depend on either a single component of the graph or the whole graph. That's up to you, but at least you have a choice now. So what we get is explicit dependencies and module resolution in Java 9. And coincidentally, this also increases the security of the platform, right? Because you now get strong encapsulation also in these platform modules. So any sensitive implementation classes in the JDK will also not be by default accessible to autocode. So this decreases the attack surface by a lot for many exploits that have been on the Java platform. So JavaScript, what does this look like if you're going to do modular JavaScript? Well, what we see here is a function, square, SQ, and we export it. But internally, it uses a secret function, which is not exported. And if we have another module, we can explicitly import from this module, square, and from this module my module, and that's based on the file name of the upper module. And we can use this square function in the lower file, but we cannot access the secret file, right? So again, we have strong encapsulation because whatever is not exported is not accessible to other modules, which is very different from the completely global scope that JavaScript had previously. So everything was just in the global scope, and you have to make sure yourself that things didn't collide and didn't have accidental dependencies. We have well-defined interfaces by means of the export statement, and we have explicit dependencies by means of the imports that you can do between modules in JavaScript. So one thing I want to address here is that, of course, JavaScript is different than Java in the sense that it's not a statically typed language. So if you want that as well, in addition to this mechanism, I would consider looking at TypeScript, which adds a layer of typing on top of JavaScript without being too intrusive. And this will give you an additional means of defining interfaces between modules. So there's also CSS modules, but let's not go there. I'm not sure whether I want to. And last, C++, right? So what we possibly get there is a module keyword defining that this will be a module called myModule. And again, we see that we can export some function from this module, the square again, but we can also strongly encapsulate other functions that are inside this module, in this case, a secret again. And instead of including header files and stuff, we get to use actual import statements between modules in C++ as well. And again, we can use the square function there, but we cannot use the secret function because of the encapsulation. So strong encapsulation again, starting to sound like a broken record, but I think it is essential to see that there's a theme under all these movements in the languages. We have well-defined interfaces, and we have explicit dependencies. So yeah, I think modules are gaining ground in the world of programming languages. And that's not just by coincidence. I think that's really something that we should pay attention to and that we should take advantage of to structure our applications, to actually make applications more manageable, and to hopefully postpone the point where we say we want to go to microservices. And remember, modules are really about the layer in between the individual objects in your application, but they are smaller than the complete application itself. And what's really cool about this is that all these nice ideas on the whiteboard about how your system should be partitioned now can actually be translated into something that is enforced by your compiler, by your runtime, and somebody will yell at you if you violate any of these drawings, right? So we want to encapsulate stuff, we want to have these dependencies, and if you violate them, the module system will help you and will point out to you, no, you cannot use that because it's encapsulated. Or no, you cannot use that because you don't have this explicit dependency. So it's not just the discipline anymore that we need to have to create these modular applications. We get actual tool support, which is essential. So Then again, we get back to the question, right? When to do modules, and when to do microservices. So what about this, it depends? I think it's fair to say, after what we've seen, that if you're going to do microservices to manage the complexity of your development, to achieve the benefits of modularity, I would say it's easier to go with a modular platform, a modular application development approach, because you prevent carving in all this complexity that we saw in the beginning about these microservices architectures, right? But there's still, of course, the question of scaling and resilience, so how do we go about that? And again, there's no clear-cut yes, no, right, wrong, binary answer here. It's really a series of questions that you should ask yourself when you're going to develop applications. What do I need and when do I need it? So let's look at some of the advantages of microservices over modules. One of the things that you can do with microservices, of course, is to choose the right stack for each service that you're implementing. Maybe it's a very good idea to implement a learning material service in Node.js and do a student service in Java and do the assignments in Python. Why not? Right? If it suits the domain. But is your company ready for this? I mean, do you really want this in production as well? Supporting 3, 5, 10 different stacks? And what happens if your rockstar programmer goes to the next startup to ruin it there? I mean, you have a problem, right? So while this sounds like a good idea on paper, I would be very careful about this in practice. Another big advantage of microservices is, of course, the fact that you have independent deployment of units, right? So we have these individual services, we can deploy them at any time, and they can run on different versions. There's no big one system, one release, one version anymore, which is nice. In practice, however, I've seen a lot of this occurring. No, we cannot deploy students with this version because it depends on learning material of another version, so we need to deploy that first, and that depends on, and so on and so on. So if you have truly autonomous services, then yes, this is really something that you can take advantage of. But building truly autonomous services is really hard, and it's really something that you need to gain experience with. So a modularized application that you can just deploy, in many cases, is preferable to having a sort of distributed monolith, where you have many services with many interactions and many dependencies. It doesn't have to be this way if you're going to do microservices, but it can very well end up this way if you don't adopt the microservices mindset. Another advantage of going with microservices over modular applications is independent failure. And this has everything to do, of course, with the fact that they're independently deployed services. So let's say we have the assignment services going down. And I don't know why, but it's just down. So in this case, we still have the 2 other services that are available. And maybe our system is able to function at 2/3 of its functionality just fine. And that's cool. But that only works, again, if your services are truly autonomous. So if this learning material service needs the assignments and thus calls to the assignment service, then it too will fail, unless you apply, of course, all the bulkheading, circuit breakers, fallbacks, etc. But again, that's a lot of work, and that's different than just picking your monolith up and chopping it into bits and pieces and just deploying it somewhere else. Another advantage, independent scaling. Since we have those nice individual services, we can run them on different hardware or different virtual hardware. So if, for example, my learning material service does some heavy lifting with graphics, I might deploy it to GPU instances in AWS, or 4 of them. And the assignment service, well, nobody ever uses that, so let's just deploy that on the T2 Micro in Amazon. Yeah, you can do that. And if you need this, then that's definitely an advantage of going the microservices route. However, it's not as if you cannot scale a modular application, right? So let's compare apples to apples. So what we do a lot is take our modular application and just deploy it on multiple nodes. Load balancer in front, easy peasy. Of course, what you don't have here is the individual tailored scaling to certain parts of your application. But in practice, this hasn't really been a problem for us. So again, it may be an issue for you, but you have to justify it, right? You have to justify the fact that you really need specific scaling for a specific service to actually yank it out of your application and turn it into a microservice. On the other hand, if you look at modules, we can look at deployment as well. And there, our life is a bit easier, of course, because in development, we had all these individual modules that teams were maybe responsible for, but in the end, it all comes together with those explicit dependencies into a single application. And this application is, of course, just as easy to deploy and manage as your previous messy monolith. Another great advantage of using modules in a modular application platform is that you have strong encapsulation still, but the boundaries are easily refactorable because the compiler knows about the boundaries between your modules, your services. And why is this important? Well, for example, look at Uber, right? This is a picture I've taken from a presentation by one of their leads. And they've gone from 0, or probably 1, service in 2014 to 1,800 services in 2016. Oh my. You can't tell me that they have 1,800 different business capabilities inside of Uber. I mean, it's a ride-sharing app, right? So what happened here is really interesting, and he talks about this in this talk. And he says, so yeah, you know what? Services are cool, and reuse is cool, but what we see happen is that people build their services, and they need another service, and there's one that's almost doing what they want, but not quite. But yeah, talking and coordinating with those other teams is just too hard. Takes too much time. We don't want to do that. So they just spin up another service which sort of does what the other service does, only better or different. And that's how you get at 1,800 services. And I truly believe that's not something that you should want in your architecture. So again, if you're in a modular application platform, your tools will help you to do refactoring across modules. And it will be good. Another example, here's Linus Torvalds. He says, the Linux project is structured so people can work independently. Torvalds explained. We've been able to really modularize the code base and development model so we can do a lot in parallel. And again, of course, Linux will never be something that will be split up into microservices. But there's also an approach to operating system development called a microkernel, where you have a very small kernel and all kinds of independent things around it, which are independent of the kernel. But that's not Linux. Linux is a monolithic kernel. But yet, they are still able to, with their tools, modularize it in such a way that many, many people, I mean, there's thousands of people working on the Linux code base, are able to work in parallel and to create working software. Another advantage of modules is that you are always doing strongly typed in-process communication between those modules. So you don't suffer the network latency, serialization overhead, etc. Unless you want to, of course. If you pick out one of the modules and create it into a service, it's a deliberate choice. But by default, these modules, they all live in the same virtual machine, etc. And by the way, have you ever tried serializing a function if you're doing functional development? So, I mean, doing microservices sort of constrains the types of interfaces that you can have between separate parts in your system. So if you do go the microservices route, I would really urge you to not just have some untyped REST interface with some Swagger documentation, because documentation is nice, but something that's enforceable by tools is nicer. So then, if you do that, look at interfaces containing protocol buffer definitions or any other type of compiler-enforced definition. In that sense, you can sort of try to mimic this in a microservices architecture, but it won't be as good as in a modular application platform. And of course, the big deal here is, of course, that things are synchronous. And it's not expensive as it would be in a microservices architecture. Because if you do synchronous calls there, it goes over the network, you have to wait for the answer, etc. That's not to say that you never are going to apply eventual consistency and asynchronous communication inside of your modular application, but it's a choice. It's your choice. You don't have to do it because it's forced by you, because there's a network in between, right? So yeah, we do have modular applications that internally have modules with eventual consistency, just because it fits the domain and it fits our scaling needs. But it's a choice that we can make. It's not something that's forced upon us by the architecture. Even if you're in a modular application, it's still a good idea to partition your data, right? So what would be bad is to have this nice modular application and this big, gigantic, single relational data model underneath it. So that's something that you shouldn't strive for. So just like in microservices, where you say a microservice should own its data, I would say in a modular application, a module should also own its data. And that leads to situations where you cannot always do cross transactions between modules like you do, like you also can do in microservices. So some of the same ideas that are applied in microservices can also be applied in a modular application platform. And last, if you have modules with those explicit dependencies, you won't run into a situation like you could with microservices, where you sort of try to deploy your system, but you maybe forgot to deploy one service, and you'll only find out at runtime, right? If somebody else tries to call it and it's not there. So if you have explicit dependencies, it means less runtime failure modes. On the other hand, it also means that if you do have a microservices architecture, you should spend lots of effort to actually make those implicit dependencies between services as explicit as possible. So you always know what the dependencies between those microservices are. So it's time to start working towards a conclusion. And one thing I saw was this tweet. And it was about a talk given by Jonas Bonner from Lightband. He gives a great talk about microservices, reactive microservices. And this guy says, oh, wow, moving from a monolithic architecture to a microservice architecture is a bit like going from classical to quantum mechanics, right? Reality. Who could argue with that? And it sounds great, right? I mean, yeah, maybe this is something that really models reality, because nothing is ever always consistent, etc., etc. But then, you know, if you think about quantum mechanics and relativity, etc., it's all about the extremes, right? So Einstein says, well, yeah, at the speed of light, everything's different, everything changes, right? Sure, but on the other hand, we still have Newton, right? Dude, the apple still doesn't fall far from the tree. I mean, for 80% of the physics problems that you have, you probably don't need quantum mechanics to get a decent answer. For 80% of the software that we're building, we don't need to be at the bleeding edge of the architectures that all the cool kids are using to get a decent answer. So don't try to solve problems that you don't have. And think about all these aspects that we discussed, right? The independent scaling, but most importantly, the modularity concerns. Try to solve them in a simple possible way. Because you're most likely not at the Uber or Netflix scale. I gave this talk yesterday in New York as well, so I was a bit worried that maybe people from Uber and Netflix were sitting in the audience, but it turned out to be fine. But anyway, most of us are not at this scale. And if we look at the organizations and the software that's being developed, I think we're looking at a long-tail distribution. So yes, there's a small part that really needs all the benefits of microservices, that really needs all the benefits of independent scaling, independent deployment, etc., etc. And for them it makes sense because they can also support this workload, right? Netflix, they built their own whole stack from the ground up to do microservices. The same for Uber, and the same for many other of those big companies. But what about us? I mean, do we build systems that really need everything that microservices offer? And do we need to pay all those costs? And sometimes the answer might be yes. Sometimes you're a bit in the direction of the yellow here. But often we try to fool ourselves into a microservices-only mindset, right? By everything we hear around us, you're only cool if you're doing microservices. And I think it's good to take a step back and think about the real reasons why you would want to make that move. And if those are about managing complexity, about making things more modular, so you can develop in parallel, so you can have explicit dependencies, explicit interfaces, etc., there are other options as well to consider. So solve the problems you do have in the simplest possible way. And I hope I've shown that microservices most certainly are not simple. Even though the concept sounds very nice on the whiteboard, in practice there's lots and lots of effort that goes into them. So at least try to read up on modular development in your technology stack of choice, whether that's Java, .NET, or any other technology stack. Because as I've shown, things are happening in this space. Module systems are becoming more and more common, and we should know how to use them to our advantage. So if I would give one advice, it would be to design your system as if they were being deployed as microservices, but first build them as modules in your modular technology stack. So think about it, right? We want to have these business capabilities with nice boundaries, well-defined interfaces, explicit dependencies, but we don't, at least at first, want to have all the complexity costs of the infrastructure, of all the concerns that come with microservices when we start building our application. And you can always move to microservices later if you follow this advice, because you already did the hard part, which is thinking about the boundaries and actually getting those boundaries right. And fortunately, if you're doing this in a modular application platform, then you get to refactor a bit instead of creating a new service every time you got it wrong. But still, this is the hard part, right? It's not about the technology. It's about really thinking about what the boundaries in your domain are. What is a sensible, what is a sensible way of chopping up my domain into different modules? And the question, of course, becomes, why do these services need to be micro anyway, right? If we have a technology stack that allows us to do modular development, I think it also makes us, gives us the possibility to scale any independent services that we do have beyond these 100 or 1,000 lines that people talk about. Because, to be fair, that sounds a bit arbitrary as well. So I think that even if you're doing modular development and microservices, they can be complementary instead of being this either-or choice that we talked about in the beginning. And don't worry, I mean, you still can do all the buzzwords, right? You can still do reactive, NoSQL, cloud, DevOps, domain-driven design. I know these are often sold in combination with microservices, but trust me, it's not a package deal. You don't have to do microservices to do domain-driven design. You don't have to do microservices to be able to use NoSQL data stores, etc., etc. Just keep thinking and don't buy all the hype that people are trying to sell you. So if there's one thing that I would want you to take away from this talk, it's this picture, right? So yes, it is true. If you have a messy monolith, if you have spaghetti code, you will hit a brick wall. And it will be impossible to, at some point, scale your application further in terms of features, in terms of development. But the answer is not always to make the jump to this microservices approach. There is a third way, which is use module systems, apply the principles of modularity, get tools that help you apply these principles of modularity, and you will be able to get past this barrier that you have with your existing messy monolith. And who knows, at some point you do want to make this jump to the microservices. And that's okay, but do it for the right reasons. And don't do it just because it's cool or because you think you need it to manage the complexity in your application. So I want to thank you for your attention. I have 2 links for you here. The first one is an article that I wrote for O'Reilly, which is really about the topic that I talked about today. It's called Modules versus Microservices. And you can pass this to your colleagues or your coworkers and discuss it. See if it still holds up when you get home, all these arguments. And the second link is the Java 9 book link, where you can get access to the early release. Chapters are rolling out on a continuous basis, and I think it's really, if you're a Java developer, it's really something that you should be aware of and you should take advantage of when Java 9 really comes out. So with that, I would like to thank you for your attention again. And if there are any questions, now's the time. No questions? Then please go have a drink. Ah, there's one question. Mm-hmm. So the question is, in this gentleman's experience, the bar of entry for OCI is quite high for Java developers. And is it the same for Java 9 modules? I think the good thing about Java 9 modules is that it will become part of the native language, right? So it's sort of something that you're forced to learn about, and developers are forced to learn about. But the hard part with OCI isn't directly the technology, it's also the modularity mindset. At least that's what I see a lot. And that doesn't change between those systems. What is different between OCI and the Java 9 module system is that OCI is aimed a lot more at dynamic module systems, where modules can go and come at runtime. And that adds a bit of complexity to the OCI APIs. That's complexity that is not in the Java 9 module system. So in that sense, it's a bit more manageable. Yeah. Okay, time for a drink.